Hey everyone, so we're going to continue our discussion of the exponential equations. Basically, we're going to do the same thing, though you'll probably see a few questions that are a little bit on the trickier end. So once again, always make sure that you work on these questions yourself before you watch this, just so that you get a chance to practice them. All right, so going through this, we're going to rewrite the 25, so that's 5 squared. Use the power rule to turn this into 4x. Now I can set the 3x minus 8 equal to 4x. Subtract the 3x over. And I have x equals negative 8. They want us to do a quick little check, so we'll do that. 3 to the negative 8 minus 8 equals 25 to the negative 8. 3 times negative 8 minus 8 is 5 to the 32nd, negative 32nd, and 2 times negative 8 is negative 16. Now, this might be a little bit too big to put in the calculator, but if you do it, you do get that these are the same number. If you have a powerful enough calculator, you should get this for both numbers. So we do get the same thing. So go down here. An exponential equation is an equation where a variable is located in the exponent. If the bases are the same, we can set the exponents equal to each other. All right, so doing some of these practice questions. This becomes 3 squared, 2x plus 1, and this is 3 cubed. Multiply everything by 2, so this becomes 4x plus 2. Setting these exponents equal to each other. And I get x equals a fourth. Over here, the 64 can be rewritten as 2 to the 6th. So setting these exponents equal to each other, we get this, add the 3 over, we get x squared equals 9. When we take the square root, we get both x equals negative 3 and x equals positive 3. So you have to make sure that when you take the square root like this, you're taking both positive and negative square roots. Over here, the 3 is by itself, but the 27 is 3 cubed. So fixing this becomes 3x minus 6. Setting these exponents equal to each other. I'm going to subtract the subtract the x over and add the 6. And I end up with 8 equals 2x. Dividing both sides by 2, I get x equals 4. All right. Scrolling down to number 2. So this one's a little bit trickier. So here we're actually solving for y, and we're now dealing with these weird rational exponents. So the top number, the way that we're going to set it, the power on x is 8. So in my exponent, it's going to be a numerator of 8. The root is 3, so that's going to go in the denominator. The number on the bottom, I'm going to use the power rule and multiply those two numbers to get 4 divided by 3. From here, I can do the quotient rule. and subtract these two exponents. So 8 over 3 minus 4 over 3. Since they have the same base, I can actually just rewrite this like 8 minus 4 divided by 3. So this ends up being x to the 4/3. Now I can go back to my original equation, replace the entire thing on the left with x to the 4/3, and so that it's going to be equal to x to the y. Same bases mean that these two exponents are the same. Okay. Moving down. We only have a few more questions left. So here, we're going to solve for m. So first step is to move the 5 over, because again, the only way that we can do this is by having one term on each side. So I have this, 27 can be rewritten as 3 cubes. Bases are the same, so the exponents also must be the same. And I get m equals 2. Scrolling down. I'm going to turn the 49 to 7 squared. So these exponents must be the same. Moving the 2 over, I get x squared plus x minus 2 equals 0. Again, because of the way things work with this quadratic, it's factorable. So we're actually going to rewrite it as x plus 2, x minus 1. So my solutions are x equals -2 and x equals 1. You should, like I said, you should always make sure to check your answers. But I know that this is what we end up getting. And that's it. Make sure you complete the rest of the questions. If you have any other questions or things like this, you're getting a little confused, please let me know as soon as possible. Thank you and have a great day.